I wanted to show a quick representation of how to show multiplying mixed numbers related to standard 5.NF.4.b, which is talking specifically about area. In the standard, it states that students should be able to use tiling in order to find area with multiplying fractional side lengths. So I'm going to show how, whenever I teach this, I always relate it to number lines. So with the area of a rectangle, when you're drawing a rectangle, the side lengths are going to be along a number line. Sorry, my focus is getting crazy. Maybe this will be better. So we start with 0. If I make this my unit, that would be 2, 3. It's not perfect. I'm not using a ruler here. And I see that one side's going past 3, so I'll go over to 4. And then I'll put my 0 up there. Along this side, I'm going to do the same. It's important that the units stay the same, so I want my 1 to be about that length. And I only need to go to 2 there. So if I were going to draw a rectangle, that was 3 1/4 by 1 2/3. Along the top, I'm going to go 3 1/4. 1, 2, 3. This one I need to split into fourths. And this is going to be the end point of one side. Along the other side, I'm going to go 1 2/3. 1. This side needs to be split into thirds, and I'm going to go down to here. So when I draw my rectangle, this can work really well on inch grid paper. I don't have that at home with me, so I'm making my own here for you guys. You don't have to draw all of them, but at least the next hole. I do want to draw both my thirds here because I have to go down to the second third. So if this is my rectangle here, now just like in that number sense routine that we were doing where we were finding the area and putting parts together, all they really have to do is count. So I see 1, 2, 3 holes. And if you relate it to partial products, this is 1 and this is 3. So it makes sense that 1 times 3 is going to give us 3. So we're doing the distributive property up here also. Then I have this hole is split into thirds. So this is my 2 thirds. So I have 1, 2, 3, 4, 5, 6 thirds, which is going to be 2 thirds times 3. Over here, remember these are my fourths. This is 1/4, and I only have 1/4 there. That's 1 times 1/4. And then here, I have 2 of these. I'm not sure what they are. So if I look here, this would be split into fourths this way and thirds this way. So there's 1, 2, 3, 4, 1, 2, 3, 12 pieces there. So I have 2 twelfths, which is 1/4 times 2 thirds. I could add these all up and find common denominators, which might add an extra step for the kids, or they can use their visual over here to help them. So if I want to make all of the pieces the same size, these are twelfths, these are thirds, and those are fourths. So I already should make sense that fourths and thirds together would make twelfths. So I could cut all of my pieces, or they can just reason through this, that there would be 3 more here because I'd split them into thirds. These would be split into fourths. So they could either show it or show reasoning here. 4, 8, 12, 16, 20, 24, 25, 26, 27, 28, 29. Did I do that right? 2 5/12 from all of my fractional pieces plus 3 more. Equals 5 5/12. I could also put these together. So that would be 1, 2, and then there's my 5/12 right there. So I have 1, 2, 3, 4 because these are thirds, 5, and 1, 2, 3, 4, 5/12. So this seems like a lot of steps, but visually it shows the students exactly how we're getting the area of this rectangle and how we're using the fractional sides to help us do that, and tiling with unit size squares, which is what the standard says.